All right, in this video, we're going to introduce inverse functions. So an inverse function works like an undo function in the sense that normally we give a function an input value, it processes it, and then gives us an output value in return. Well, an inverse function acts like a refund, if you will, where we can take our output that we got, put it in our inverse function, and then get our original input back that we started with at the beginning of the problem. So if we want our original value back, our original input back, we can give our output to the inverse function and it'll process it and give us our original input back. So we're going to create these undo functions, if you will. So for instance, let's say we have an original function where we square whatever we give it, so a squaring function. So if we give our original function a 10, it'll square it and give us back 100. Well, if we have 100, but we want our 10 back, or whatever the value is, then we need to run our 100 through our inverse function. And the inverse function that's going to undo the squaring is square rooting. So if we give 100 to our inverse function, we take the square root of 100, we're going to get our original 10 back. So, and that'll be true for any value that is in the domain of our inverse function. So mathematically, two functions like f of x and g of x are inverses of each other if both of the following are true. So if the composition g of f of x is equal to x for all the values of x in the first function's domain, and then f of g of x equals x for all values of x in the domain of g, then f of x and g of x are going to be inverses of each other. So in other words, going back to what we have up here, if we take the square root, or we take x squared and plug it into the square root of x squared is going to give us x. And then if we plug the square root of x into x squared, the square root of x squared will give us x as well. So that means these two functions are inverses of each other. But just, think of it like this. You'll get your original input back if you give your output to the inverse function. That's exactly what all this is saying. So in this first video, we're going to focus on determining whether or not a relation or a function has an inverse. So way back when we looked at relations and to determine whether or not they were functions, they had to pass the vertical line test. So in other words, every vertical line that we draw could hit the graph at most only once, then the relation is a function. Well, for a function to have an inverse that's also a function, it has to pass a similar test known as the horizontal line test. So the horizontal line test says if every horizontal line you draw intersects the graph at most only one time, then the function has an inverse. Very similar to the vertical line test. It's just we're drawing lines left and right versus up and down. So we have some synonyms for a function that passes the horizontal line test. It's said to be invertible or one-to-one. So passing the horizontal line test is the same as invertible and is the same as one-to-one. So in different contexts, you might see these vocabulary words and phrases here. They mean the exact same thing as the function passes the horizontal line test, which means its inverse is also a function. So example 1, determine if the following relations or functions have an inverse. So we have f is negative 1, 1, 0, 2, and 2, 1. If we look at the plot of these, we see that we can draw a horizontal line through these 2 points, which means we don't have an inverse. So when we looked at the vertical line test, we focused on the x coordinates all being different. With the horizontal line test, all the y coordinates need to be different. So see, we have a 1 for a y coordinate at this point. We also have a 1 for the y coordinate at this point, and that's going to mean our relation's automatically going to fail the horizontal line test. Part B, f of x equals 1 minus 2x over 5, and I would advise you to graph this. Here's what the graph looks like. It's a line. Every horizontal line we draw is going to hit it at most only once, so it does have an inverse. Part C, we have g of x equals 2x over 1 minus x. Here's the graph of that rational function. We draw a bunch of horizontal lines. Notice the horizontal lines only hit the blue graph each time at most once, so this does have an inverse. Finally, part D, x squared minus 2x plus 4. Here's the graph of that. And if we look, we can pick a horizontal line such as this one. It's going to hit the graph twice, which means it does not have an inverse. So we're going to have to do some domain restrictions on the ones that don't pass. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.